Okay, 10 to 10:50. I think 50-50. One more time.
Tiebreaker.
Okay, 9 to 9:50, guys, again, one more time. Okay, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. Okay. 10 to 10:50.
Bro, there's no question.
Okay, I see some vote. So, all in favor, 10 to 10:50, say aye.
Aye.
Anybody opposed?
You should vote the coin.
No. No.
Okay, okay, I
Ew,
have
I
it,
know.
10 to 10:50, okay.
Three
That's
times,
okay.
huh?
It doesn't matter for you. So we'll have class from 9 to 9:50, okay? And there are 5 problems. Okay, you see the problem number 1. I'll give you hints, guys. Please pay attention. 15 and then all, most of them 20s and.
It's okay, AJ, I got it.
So this may change a little bit depending on how far I go today. Okay, so you are allowed to bring 1 page of formula sheet. Okay, so the type of problem that you have, like you do not, if you practice, those are trivial formulas that you need. You do not need a formula, but you can bring formula. No examples in the formula sheet. You cannot bring the solution of examples or solution of problem. And no Python code. No Python code and no solution of examples of problems. So bring just formulas that you feel challenging. But for example, finding probability, the length of set A over length of like cardinality of sample space. You should not write this sort of formula. Okay, so trivial formulas you don't write. Write the complex formula. For example, binomial, for example, PMF of a binomial distribution. Okay? So you can just write m k and p to the k and q to the n minus k. This sort of formula you can write. Okay, so that's all, and I have with 1 page 8.5 inch by 11 inches, and then bring calculator. Borrowing calculator will not be allowed, and make sure you bring working calculator. Okay, cell phone as a calculator will not be allowed. Cell phone will be completely turned off, switched off. Also, exam will be in the junior. Okay, you guys know where is our junior lab, right? Where you have EC 3 lab. It's going to be in the junior lab. I'm going to send you an announcement. I'm going to send you an email. I just need to get a confirmation from all the faculty that during this 2-hour time slot they will be not. Okay. So exam is going to be in the junior lab, and the class is going to be in the junior lab for Monday only. Okay, so I am going to close just to be on the safe side so that I will show you the question. All right. So that I don't forget, I have posted the computer assignment on chapter number 3. Assignments. do you guys recall that computer assignment number 1, I said, that you submitted computer assignment already. And I said that I posted some practice problems here. These are end of chapter problems. Okay? So you do not need to submit the solution of these end of chapter problems, but these are some practice problems that you should go over. These are end of chapter problems. Also, this is from chapter 1, this is from chapter 2. Also, in computer assignment number 2, I put computer assignment number 2, I have listed some end of chapter problems just for your practice. Okay, so make sure you solve these problems. That you'll have good practice for the exam. In addition,
On the exam, are you gonna have us handwrite a Python program?
I will go over that.
Okay.
I will go over that. So, in addition, make sure to practice the homework problem set 1, problem set 2 that I have posted. Okay? So you submitted homework number 1, list of problems, and homework 2 is due today, right? So this will help you. So the homework 2 is basically from chapter number 3. Now let's review. So first chapter, you can just skim over this first chapter. Don't pay too much attention on in the first chapter. Only thing that you could review is relative frequency and related problem. Other than that, you don't pay much attention in chapter number 1. So you go directly to chapter 2. Okay. So this from chapter 2 you should focus. So in chapter 2, set theory is important. Set theory is going to be important. Set theory, make sure you know all these operations, complement, disjoint, intersection, union, you know that it should be like this at this point. And then what you do, so examples, these examples are part of homework as well. So make sure you practice those examples. Do not simply skim over those examples. Make sure you take a piece of paper and solve. Otherwise you will have problem. So if you simply skim over it. So I believe in doing it instead of just skimming over it. I will not be asking you questions. I will not be asking you questions like write De Morgan's rules. No. So mainly like problem-based, numerical problem-based questions you can expect. So make sure you go through all the examples and suggested problems. So here you see that I went through all these examples, and then this section I did mention in class that you omit this part. So I did not prepare any question on computing probabilities using counting method. We already did some of these, we skipped, okay? So I will be preparing questions, and I prepared some questions already based on the topics that I will address. Okay. Now, from chapter number 2, I did not go through any Python code basically. So only Python code that I have right here, but Python code in chapter 3 is going to be more important than what you see here. Okay. So So I'm going to show you what sort of code you should focus on. So, sequential experiment, we went through this example, and Bernoulli trial, very important, Bernoulli trial, and also how to make use of binomial theorem. And after that, this is the topic that we did not go through. Probability generating function. Probability generating function, we did not go through this topic, therefore I will not be giving any, and I did not prepare any question on this topic. So, random number generator use NumPy package, but Python related code, you probably have one question related to Python where you may need to write 5 to 10 lines of code maximum. Okay? And it's going to be from chapter 3. So whatever code that you see in chapter 3 is going to be from chapter 3. So make sure you know exactly how to import packages. And there are, you know that there are many packages in Python, but you will be using the packages, the questions, if I have questions, I will be asking you the packages that you use. For example, NumPy package we use, right? We use NumPy package, we use what other packages? SciPy statistics packages we use. So these are the two packages basically we use. So you should know how to import them. You should be able to write it down. Okay? So you will not have computer, you will have to write this code in the example. Now, go through this example. As I said, I'm not going to reiterate. So, for example, we did talk about these iteratives, import product. Okay. If I ask you to write, I will not be asking you to write a print statement. Mainly, I will focus on, for example, how you join this product using join syntax. Okay. For example, count syntax. What is count? Here it counts number of pairs in each of these outcomes. Okay. So forget about this print statement. I'm not going to ask you print statement. I will mainly be focusing on this sort of syntax. For example, join account, and here from these topics. So these topics are very important. So these topics we have Bernoulli, binomial, geometry, and Pascal. I did not prepare any question on Pascal, so therefore you will not pay attention to Pascal. But these are the three random variables that you should focus more on. So therefore, Bernoulli random variable, I went through these examples and again solve the corresponding problems from end of chapter problem that I mentioned in the completed assignment. Yeah, here you see the solution, how I solve. And when I ask you to write range of random variables, make sure you use this notation. S for sample space, and if you write S subscript X, which means that it is the range of random variables. Make sure you pay attention to the notation and stick to the notation that I have in my slide. Geometric random variable, we went through geometric random variable. Okay, so the examples, make sure you solve those examples. But what I was mainly talking about, for example, how to import this statistics package, and how to import this binomial, and how to make use of this binomial, how to write the range. So what is the syntax to come up with to write the range of random variable. Okay, so if I give you certain values, if I give you one example, you should be able to know what is n, what is the value of p, what is the range. Print statement, I will not be giving you, but I would probably be asking you to write this sort of syntax. And PMF values. PMF values, how to determine the PMF values using binomial module. From binomial module, you have PMF method, already PMF method. What are the parameters? Make sure you know which parameter is what. If you simply swap it, it's not going to work. You have to write exactly. So, exactly this syntax. And then, a print statement, and looping structure, I do not plan on giving looping structure. But we went through CDF, cumulative distribution function, so make sure you know how to make use of CDF. Okay? Not print statement, how to make use of CDF. I will be looking at this variable and how you make use of this CDF method with parameters. See here, one is basically whatever you see here, and then n is the number of the random experiment has a random variable that follows binomial distribution, so you know the total number of trials and you know the success probability. So you pay attention to those parameters. Uniform random variable, Poisson random variable, Pascal random variable. I said that I did not go through it. So you may want to just omit this part. Poisson random variable, very important. And how you make use of Poisson random variable, just like binomial random variable, how to import Poisson random variable. And then how to get the range using a range command as well. And then how to come up with, how to determine the PMF based on the average number of events. So second argument is the average number of events, and the first argument is the range of values. So I will not be asking you how to plot. Okay. So this plot syntax you may not focus on, but make sure you focus on the syntax of binomial, PMF, CDF, or binomial random variable, Poisson random variable, uniform random variable, geometric random variable, and so on. So, yeah, there are some related examples. Do not forget to solve those examples and corresponding end of chapter problems. And then we have expectation operator, and sometimes I denoted the expectation with mu sub x, which is basically expectation of random variable x. So go through the example how to determine the expectation of a geometric random variable. So if x is a geometric random variable with parameter p, so how to find the range, how to find the PMF of random variable x taking value x, and how to find expectation, which gives the mean of random variable x, how to find the variance of random variable x if x is the geometric random variable. Yeah, I summarized all of these for all the random variables, all the important random variables in the end of this chapter. So, how to make use of geom module from statistics package. So you need this success probability because geom random variable takes only one parameter. and then you have how to make how to determine the mean. You see, mean, there is a method called mean of geometric random variable in case you have Python related question. So maximum you can expect 5 to 10 lines of code. I'm asking you. So yeah, so this is important. Expectation of how to determine the expectation of a random variable that is a function of another random variable. There are two ways. One way is determine the PMF of random variable. You would say you have seen some examples already, and there are some end of chapter problems as well. You have seen how to make use of how to determine the PMF of a random variable, which is a function of another random variable. So once you determine the PMF, you just use the formula of expectation of this random variable using just conventional formula. So this is one way. The other way is directly. For example, you can bring this sort of formula, for example, in your formula sheet. You can directly write this formula to determine the expectation of a random variable, which is a function of another random variable. Here, for all values of x, you just pass this x value to the function, and then PMF, you multiply to PMF. So we went through this example, and there are similar examples for when z is a function of another random variable. So please solve this example. Variance, these are the formulas of variance. So here you have variance. Variance is basically expectation of a function of another random variable, but this function is basically g of x is x minus mu sub x squared. So you can just use the same formula of expectation that you used to determine the variance. So this is the formula for the variance, and standard deviation is basically the square root. Okay? And we went through some properties in case I asked you to find the variance of a random variable that is a function of another random variable plus some constant. You know that how to utilize this formula. Okay, so these are the properties you need to export, and there are corresponding examples. Conditional probability mass function. So this is the topic that I did not go through in class. So you may omit that. Yeah, this is the topic that I did not go through. So I summarized all these random variables here. So for binary random variable, how to determine the range, how to determine the success probability and failure probability, what is the expectation and what is the variance in case you have binary random variable. For binomial random variable, same parameters. So I just summarized them. For Poisson random variable, you see I have similar quantities that is given. So for Poisson random variable, expectation is basically simply average number of events happen in a particular time slot. So for uniform random variable, we have here, and then generation of discrete random variables use Python. So this is part of actually your computer assignment number 2 is based on discrete random variable that you use in Python. So next, chapter number 4. Chapter number 4, we went through cumulative distribution function. Very important. We went through cumulative distribution function in case we have a binomial random variable, how we find the cumulative distribution function. Make sure you know the definition of cumulative. What does it mean? F sub x is basically, it determines the probability of random variable x taking value x for all values of x from the then so we have the CDF, we have another, this example I went through. The previous example was special case of this example. So I went through that. And if I ask you to determine PMF, if I ask you to determine PMF, make sure, guys, if I ask you to determine PMF of a random variable, make sure for discrete random variable, make sure for all the PMF values of random variable x can take any value from the range. So summation of all the PMF should be 1. Make sure you check, double check this. Otherwise, that way you know that your answer is 100%, PMF is 100% correct. And for CDF, you make sure you cover f sub x, which is basically probability of random variable x taking variable x less than or equals x for all values of x from the entire real line. Okay, so here you can write the CDF mathematically. I went through a bunch of conditions, right? I went through some examples, right? When if x less than 0, for example, if x 0 less than or equals x less than or equals 1, right? Bunch of conditions, right? You remember? I went through one example. So where I covered the entire real line. When you determine CDF, make sure you cover the entire real line. Otherwise, that definition of CDF is not correct. So CDF, here you can see that again we have another way of determining CDF for the same binomial random variable that we covered in chapter number 3. So here you come up with a range and you determine the PMF values, and you can use the NumPy package instead of binom module. You can use NumPy module as well. And in NumPy module there is a function called cumulative sum. Okay, this cumulative sum, you just pass these PMF values. This cumulative sum will determine the CDF values. So the way cumulative sum works is, for example, 0, 1, 2, 3. I'm just giving one example how cumulative sum works. For example, S equals this, and then if you use NP dot cum sum, and you pass S, so it will give you 0, and then 0 plus 1, 1 plus 2. Okay, 0 plus 1 plus 2 is going to be 3, and then you add all these 3, so 3 plus 3 6, like that. So it will give you cumulative sum like that. You understood, guys? Okay. Once again, I am not going to ask you to write commands for plotting. Okay. So you may want to discuss the plotting function because you will be using computer experience for that. So I just focus on a range, like how to use different modules and different methods, PMF, CDF, PDF, that I will go through today. Yeah, that's all. So, yeah, so this example is very similar to the previous example. So make sure you solve this example. Example 4.4, and there is a similar problem from the end of chapter problem. So make sure you solve this, and then today I am going to go through another way of determining CDF. So that's where today's lecture starts. So I don't have much time, so I will not be able to cover much material. So here, look, CDF,
Is this part gonna be on the exam?
yes,
Okay.
yes, whatever I cover until, what, 10:50, it's still 60 minutes. So, CDF, CDF of discrete random variable can be, this is another formula that you can write it down. So in case you have range S sub x equals, let's say, x1, x2, dotted, and so on. You can have many values inside this range set. So for each of these values, as long as xk less than or equals x, you sum them up, you get this CDF. But you can simplify this, you can just make use of these indices, you can simplify this and use the step function. The step function, you guys knows what is the step function. Step function is going to give you 1 when x greater than equals 0, and it is going to be 0 otherwise. So that's what the step function was. Now, so I will show you how to make use of this formula through the similar example that we had previously. See, in this example, I just took this example. This is not from the book. In the book, there is different example, but I just took the previous example. But here, I am going to show you how to write this CDF using step function. Look, guys. So let x be the number of heads in 3 tosses of a fair coin. Write the CDF of x in terms of unit step function. Okay, what sort of random variable it is, guys?
It's a binomial.
Binomial random variable. Binomial random variable with parameters n, p. Okay, it is fair coin. So therefore, n equals, here n equals 3 and p equals 1. Success probability is p. So p is the success probability. Write the CDF of x in terms of unit step function. Guys, look. To write the CDF, what do you need here? You do need PMF and you do need this x case. So do you guys remember the range of the range for this binomial random variable? It is going to be, it is number of heads in 3 tosses of a fair coin. So number of heads could be 0, 1, 2, 3. Okay? So you can just think of this as x1. This is x. We can go to different color. x1, x2, x3, x4. We had this example previously, but here it's a different way of representing CDF. Okay. Now, to compute the CDF, look, we do need this PMF. PMF of random variable x taking value xk. So PMF of random variable x taking value 0, which is the first one, this is x1, is going to be 3, 0, half to the 0, half to the 3 minus 0. So you compute that. Okay. So PMF of random variable is taking value 1. So this is the next one. So 3, 1, half, 1, 1 minus half to the 3 minus 1. Can you tell me what it is, guys? So this is 1/8 and this is 3/8. And then PMF of random variable is taking value 2 is going to be 3, 2, half to the 2, 1 half to the 3 minus 2 is going to be 3/8 as well. And PMF of random variable is taking value 3 is 3, 3, half to the 3 and half to the 3 minus 3 is going to be 1/8. So if you sum them up, you see that they are 1. If you just add them up, they will be 1. So therefore this PMF is correct. Now, you just use this formula. Here, K varies from 1 to 3. You have actually 1 to 4. X1, X2, X3, X4. X1, X2, X3, X4. So you just directly use this formula. So now CDF f sub x taking value x is by definition it is probability that x less than or equals x for this lowercase x can take any value from the real line. So you directly apply this formula. K equals 1 to 4. You have PMF of random variable x taking value xk and then u x minus xk. And then I am going to write f sub x taking value x is, you can just expand it, you say that it is PMF of random variable x taking value xk equals 1 which is 0 and u x minus 0 plus PMF of random variable x taking value 1 u x minus 1 plus PMF of random variable x taking value 2 u x minus 2 plus PMF of random variable x taking value 3 u x minus 3. This is basically, it's a summation. Previously you saw that it was using case, you wrote bunch of conditions. Now here it's basically summation of a bunch of components here. So PMF of random variable is taking value 0 is 1/8 u x plus this is 3/8 u x minus 1 plus this is 3/8 u x minus 2 plus this is 1/8 u x minus 3. So this is your f sub x, and that's your final answer. So this is another way of presenting. Another way of representing CDF. Yeah, it's not in my slide, like I gave enough information. If you just practice well, okay, you understood the topics, you guys should be okay. So practice is important. All right, next. Continuous random variable. Here is one concept. Okay. I have an interval from 0 to 1. Okay? 0 to 1, I can take any value from 0 to 1. Okay? Continuous random variable, guys, very, very important. This is where the concept differs right here. So, continuous and discrete random variable. So I have 0 here, 1 here. So in this interval, what is the probability? I can take any value. The range is basically S sub x. Range is basically 0. And x can take any value. I just pick a number from this range. My question to you, let's say I'm giving here x equals 0.5. My question to you, what is the probability that I will be able to pick x equals 0.5, exactly 0.5? What is the probability?
Very small. It's like an infinite amount of value between 0 and 1.
Yeah, so 0 and 1, I'm asking that what is the probability that I would be able to take, I would be able to pick exactly 0.5. This probability is 0. It's 100% guaranteed. Why? You will never be able to pick x equals 0.5. It's going to be either 0.499999999999999 and so on, or 0.5, 0.0000000000000. It will never be exactly 0.5. So for continuous random variable, probability that for discrete random variable, we found that the probability that for discrete random variable, we found that probability x equals 3. We found that it was 1. Okay. For continuous random variable, it was discrete random variable for coin toss. Coin toss, we tossed coin 3 times. For that was discrete random variable. It was discrete. Okay. So for discrete random variable, it is okay that we can write it like that. But for continuous random variable, if you see probability that x equals sign x, it is 0. You can just close your eyes and you can write 0. It's guaranteed that for continuous random variable, if you have this equal sign, that probability is 0. It is guaranteed because you will never be able to pick exactly that value. Okay, so that's one fundamental difference between continuous random variable and discrete random variable. And for continuous random variable, look in the previous example. For discrete random variable, it was just summation. You see, for discrete random variable, it is summation. But for continuous random variable, if x is a continuous random variable, not discrete, x is a continuous random variable, it is probability that x less than or equals x. Okay. See, this x can take any value from negative infinity all the way to x. So that's why summation is going to be replaced with a integration in continuous random variable. In continuous random variable, summation is going to be replaced with an integration, and lower limit of the integration is going to be negative infinity, and the upper limit of the integration is this one. Is this x. This is the upper limit. So this is basically the upper limit of the integration, and lower limit is negative infinity. And if you have mixed type random variable, the expression is such where alpha can take any value between 0 and 1, not including 0, not including 1. So now probability density function, when it comes to probability density function, so this is what we are going to utilize. Probability density function, we need to keep in mind that probability that x equals 0 is going to be 0. for all x in real life. Now, definition of probability density function, it is simply a derivative. It is simply a derivative of the CDF. You take the derivative of CDF with respect to x, you get the PDF, probability density function. I have a small example that follows, okay? But should I go through another example? If I go through another example, that is going to include syllabus. Should I go now? I have 30 seconds. Okay, that's it. So here, up to this point, and I updated my, I uploaded my slide on the Facebook. Okay, so up to 1.130, so make sure to do that. And then I just have to update my questions. So I will see you at 9 o'clock, okay? 9 o'clock we'll have class from 9 to 9:50, and then we'll start the exam.
Two days before you.